Hello my dears. We have to mention some terms regarding the circuit breaker so that in future if some relation we have to make what happened when this increase and all. So for that we need some knowledge about the terms, some terms. First one, recovery voltage, my dear. Recovery voltage. Recovery voltage. It is the RMS exist between the contacts after arc extinguished. After the arc extinguished. So recovery voltage is nothing but, my dear, I already told you in the circuit breaker session that there is a break in the circuit, there will be an arc. So as soon as we have to remove this arc, so that there will be an insulator, so that the circuit will be in break condition. So at that break condition, as soon as the arc extinguished, okay, after the arc, as soon as after the arc extinguished, the voltage between these two fixed contact is termed as the recovery voltage. That's after that the arc extinguished, there the voltage in between two fixed contact is called the RMS value of voltage in between these two fixed contact is termed as the recovery voltage. Okay, and next one, active recovery voltage. It is the instantaneous value of recovery voltage after arc extinguished. And active recovery voltage is represented like K1, K2, K3 into Vm sin phi. Vm sin phi, where Vm is equal to VL by root 3 into root 2. Because this is nothing but, my dear, we have the basic equation Vrms equal to Vm by root 2 now. So Vm will be Vrms into root 2. That line to line Vrms, line to line voltage is nothing but the RMS value of voltage. This Vrms into root 2. If it is a star connected system, means the phase voltage is nothing but line voltage by root 3. Correct now? So combined it together, we will have Vm is equal to Vrms into root 2 or VLL into root 2. Sorry, V phase into root 2. Vrms means phase value of voltage. Vrms means here phase value of voltage. Correct? Vrms means phase value of voltage. Okay? So this will be equal to Vm is equal to Vrms into root 2. We have to convert it to line quantity, so that VLL by root 3, because it's a star connected system. Line voltage equal to root 3 times phase voltage, so that phase voltage will be line voltage by root 3, simple. Line voltage by root 3 into root 2 will be the Vm. And K2 will be 1 for LG or LG fault. Okay, and it will be equal to 1.5 for LL fault. That means whenever there is a ground included in the circuit, ground fault included in the circuit, the value of K2 will be a constant. Now these all are constant, so K2 will be 1, otherwise K2 will be 1.3. K3 will be equal to normally 1, and K1 will be equal to recovery voltage divided by rated system voltage, and its value will be always less than 1, and its value will be what, my dear? Always less than 1. So these are the three constants we are facing for active recovery voltage. Some constant K1, some constant K2 and K3, that is K2 is equal to 1 and 1.5. So we can say this, and K3 will be mostly 1. K1 will be recovery voltage by rated system voltage. Recovery voltage is nothing but, we already told you, this is the RMS voltage in between the contact whenever the arc extinguished or soon after the arc extinguished, but that will be always less than the rated system voltage now. See, always the terminal voltage will be less than the applied voltage now. That's simple principle. So that K1 will be always less than 1, because this will be greater and this will be lesser. This will be greater and this will be lesser. So simply less than 1. That's all. And phi is nothing but the power factor angle. And power factor angle. So you have to note one important term here. Important term here, my dear. The active recovery voltage is depend upon the power factor. That's the active recovery voltage depend upon the power factor of operation. The power factor of operation. That also you have to note it down. So that's all about the active recovery voltage. Okay. Next one. Next we have to see, my dear, another term regarding the circuit breaker, which is nothing but race tracking voltage. Race tracking voltage. So race tracking voltage, you can write the definition here. It is the instantaneous voltage exists between contact during arc extension or interruption. During the arc interruption. So what is meant by this race tracking voltage, my dear? I will tell you. A very good example you can see in the nature itself. That is nothing but whenever you are blow, that means you have to blow a candle. No? You have to blow a candle. It will not go off, right? So chimney, small chimney in our chimney lamp in our old home and all, few years back, you remember that, right? That chimney lamp I will draw here. This will be the chimney lamp. Okay. If you start blow it will not suddenly off. If moderately if you blow, right? Okay. Suppose suddenly you blow means it will definitely vanish. But if you slowly blow means it will start vanishing, and if you release, if you stop blowing, it will again burn. If you again you do this, it will start fading and you release means it will again blow. It will again blow. I mean, this will not fade. This light will not fade. So that same thing will happen in the arc also. The arc suddenly not break, my dear. The arc here, it exists an arc here. The arc suddenly will not break. That means this is the arc. This is the arc. And this is the two contacts. The arcs will not suddenly break. It will break and it will again it will break and it will make. Before it can permanently break, some few break and make cycle will happen in between. That voltage, at that time there will be some voltages in the terminal. That make and break happening during the arc interruption. That during is very, very, very important term. So during the arc interruption, that make and break process will continue for very, very small duration of time in the range of nanoseconds, depending upon the capability of the circuit breaker. That make and break time now, at that time the terminal, there will be some voltage existing between the contact. That instantaneous value is nothing but the restriking voltage. And there is an equation, my dear. For restriking voltage there is an equation. Restriking voltage, RSV, I can say like this: active recovery voltage into 1 minus cos of T by root LC. This is the expression for the restriking voltage. This is a very important relation because it contains the term of root LC, because this making and breaking process is something regarding with the LNC operation. The presence of LNC is actually the reason for the making breaking of the arc. If it doesn't contain any LNC, means nothing, my dear. There will be what? A continuous blow or a continuous off. There will not be any make and break system. The chimney, there is no LNC. Just for our understanding purpose, I told about the chimney. Okay, sir, eraser, where is in chimney LNC? You can see, no, you can't see that. You can't see any LNC there. It is just for our understanding purpose, I told you. Right? So this is very important relation, my dear. Just remember it. Okay, this is very, very important relationship. So that is nothing but the restriking voltage. Okay. Next, we have to see another very beautiful term. It is nothing but rate of rise of restriking voltage. What was that, my dears? Rate of rise of restriking voltage. Triple RV. RRR, that movie. It's a triple RV. Triple RV. Rate of rise of recovery voltage, my dear. So actually, rate of rise means something, but at what restriking voltage now? That in what rate it is happening, that is nothing but the rate of rise of restriking voltage. And there is also a beautiful expression: rise of restriking voltage will be equal to 1 ARV by root LC sine T by LC. So this is the equation for what, my dear? A rise of restriking voltage is also very, very important relation. Rate of rise of restriking voltage. Okay, this equation can be utilized in many of the situations. What happened when L and C is very high? What happened when time is very high? What happened to the rise of restriking voltage? No? A beautiful question can be read. See, in examination we asked, what happened if the capacitance in the circuit is very high as compared to the inductance? Then the rate of rise of restriking voltage will be low. If denominator is high, means it will be low. If denominator is very low, means it will be very high. So the likewise you can connect. Okay, is it clear, my dear? Is it clear that? So that's the very important term which is connected to the circuit breaker. And one more term is there: current chopping. This is for just your understanding. Current chopping means so the breaking of the circuit before current 0 point. That means for AC cycle, you can see that here there is a naturally zeroing point. This point are there, natural 0 points of current. If we interrupt the circuit, if we break the circuit before this natural 0, it may be like here, it may be like here, it may be like here, it may be everywhere, or it may be like here, it may be like here, it may be everywhere. Rather than this natural 0 point, if you try to break the circuit, what happens? More and more arc will produce because the current is not 0 there. So what happened? A very huge arc will exist in between the fixed contact of the circuit breaker, and eventually there is a chance of, if you continuously do it, that is a current chopping, you continuously do it, what happened? The permanent points or the fixed points of the circuit breaker may slowly deteriorate, and finally it will blow off completely. It will deteriorate and it will vanish. I mean, it will destroy. So always remember that you have to operate the circuit breaker at the point such that the current attains the natural 0. So this point or this point, the circuit should be break. The circuit should be break. Okay. Okay, my dear. Next term associated with the circuit breaker is, we'll tell you. Next term is associated with the circuit breaker is symmetrical breaking capacity. Symmetrical breaking capacity. That is the RMS value of current exists between the contacts when the circuit or during arc. That's all. So this is nothing but my dear, it is the RMS value of current exists between the contact during arc. So normally the symmetrical breaking capacity expressed in I, either I or MVA. Both are we can use. Either I or in MVA, the symmetrical breaking capacity is used. Another term is nothing but, my dear, symmetric making capacity. This is very, very important. Actually, making capacity is very important than the breaking capacity. That means it is the, you can say that it is the it is equal to, that is the making capacity. Making capacity equal to 2.55 times breaking capacity. 2.55 times the breaking capacity. Or in words you can say that it is the current exists between the contact when the contact makes contact again. That's all. The same thing you can apply here now. It is the RMS value of current exists between the contact during arc. During arc there will be current, and symmetrical making capacity means it is the current of the current after the making of the circuit. That means during the breaking there will be arc, there will be a small current. Of course we know that current is called the making current, breaking current. When the arc completely extinguished, the fault we removed, the contact again this will be in connecting after some time. At that instant of connection there will be a huge current again flowing in the circuit. That current will be 2.55 times of the breaking current. That's all. That will be greater than the arcing current. That's all. Simple. So making current will be 2.55 times of the breaking current. This relationship now, my dears, this is very, very, very important. A one word question also directly you can ask from this equation. Symmetrical breaking capacity is equal to 2.55 times of symmetrical breaking capacity. Numerical will be asked from this. They may give the symmetrical breaking capacity and you want to find the symmetrical breaking capacity. Simply multiply it with 2.55, you will get the answer. Simply multiply it with 2.55, you will get the answer. That's all. That's all. Okay? Is it clear? So that's all about the some important terms regarding the circuit breaker. Now we are going to briefly explain different types of circuit breaker, because if you talk about circuit breaker very detailed means it will take hours, but for competitive examination point of view we will not need that much content. We just need some important value, and I will explain now. So types of circuit breaker. Types of circuit. First one, air circuit breaker. Only you have to remember the voltage rating at which we are using the circuit breaker, that's all. So it will be less than 66 kV, you can go for the air circuit breaker. Next one, air blast circuit breaker. That is nothing but my dear, less than 220 kV. And SF6 circuit breaker, CB directly SF6 circuit breaker, which is nothing but my dear, less than 200 kV. You can use that. And oil circuit breaker, oil circuit breaker, use it for 66 kV again. And finally vacuum check the spelling, okay, correct or not. Vacuum circuit breaker, and you can use it less than 30 kV, less than 30 kV. So these are the important types of circuit breaker, my dear. Air circuit breaker, air blast, and or this air circuit breaker also called air brake also, my dear, air brake circuit breaker, or next one air blast circuit breaker, and this is SF6 circuit breaker, oil circuit breaker, and vacuum circuit breaker. Okay, and this is, you have to note it here, used in traction. And this oil circuit breaker used in distribution. And this vacuum less used. And this is commonly used. Commonly used. That is the most dominant used is air blast circuit breaker, and not that much dominant we are using is less used, or this is a vacuum circuit breaker. Okay, so that's all about the circuit, but only you have to remember this voltage is very important, and where it is used also very important. This is in traction purpose, this is in distribution side oil circuit breaker, and the voltage rating, my dear, this is you have to note it down. This is very important. Air, simply air angle 66 kV and air blast and SF6 and oil circuit breaker and vacuum circuit. That rating is very important, my dear. Okay, so that's all about the circuit breaker. Okay, so from next class onward we will talk about the relays. So thank you.